Alright, when adding or subtracting unlike fractions, unlike meaning they have different denominators, you have to convert them to a common denominator. We're going to use something called the least common denominator. This is essentially the smallest number that will work. The rest of this is just kind of describing that. This is called the least common multiple, or the least common denominator. These are LCM and LCD are kind of interchangeable in our purposes here, but multiple is, well, the multiples of a number. The multiples of 2 are 2, 4, 6, 8, 10, and so on. The multiples of 3 would be 3, 6, 9, 12. So the common multiples here, 6 is a common multiple, and 12 would be a common multiple between them. The least common multiple, though, would end up being 6. So the least common multiple of 2 and 3 is 6. This is kind of where that language comes from. However, that's not how we're actually going to find the least common multiple. It can be a very cumbersome process actually listing out all the multiples and figuring out which one comes first. We're instead going to be using that prime factorization that we just figured out how to do. So if we wanted to, if we had 24 and 40, and we had the prime factorization, so you can see that's already done for us here, then to find the least common multiple, we're going to look through this and say, okay, I want everything that's in these lists to occur in here. But I don't need, if it occurs in different numbers, well, let me explain. Let me start over here. I have 3 copies of the 2. 3 factors of 2 within that 24. I also have 3 factors of 2 within the 40. Well, if my multiple has 3 factors of 2, that means both of these, or this will be a multiple of these other things. Alright, try this again. I'm going to go through each of these factors, each of these prime factors. I'm going to look at my 2's and say there's 3 2's here, there's 3 2's here. That means I'm going to need 3 2's down here. Look at my 3's. I have 1 3 up here. I don't have any 3's up here, but I need to make both of these happy. So that means I'm going to have 1 3 down here. So when I say making it happy, I need to have at least 1 3 in order to make this one happy. I have to have at least 0 3's in order to make this one happy. Well, if I have 1 3, I make both of those happy. So that kind of actually explains why, even though I have 3 copies of the 2 here, I need at least 3 2's. This one also says I need at least 3 2's. Well, if I have exactly 3 2's, then then I make both of them happy. The fact that this is the least common multiple means I want to deal with the smallest amount of multiples here. So I want to go with the smallest number of 2's that will make both of those happy. That's why I'm sticking with 3. I'm going to want to go with the smallest number of 3's that will make both of these happy. That's why I'm going with 1 3. And I also have to have a 5 in here because I need to make this one happy. I have to have at least 1 5 to make that one happy. Alright, clear as mud, right? Alright, so if we wanted to find the least common multiple of these, I would start off, well, actually I should finish that up. The least common multiple is what we get when we multiply all these together. So 2 times 2 times 2 times 3 times 5, whatever number that ends up giving us. 120. So 120 would be the first number, the smallest number that is a multiple of 24, and simultaneously not a multiple of 40. Alright, so if we want to find the least common multiple of 3 and 4, well, 3 is prime, and 4 is equal to 2 times 2. So if I'm finding the least common multiple here, I'm going to start by looking through my primes and say this one doesn't require any 2's, but this one requires 2 2's. I need both of them to be happy. It requires at least 2 2's, I should say. In order for both of them to be happy, I want 2 2's. I also want the 3 from that one. So the least common multiple here is 12. And at first glance here, it may appear that I'm just multiplying these two numbers, but that's not always going to be the case. This next example, you'll see that. 8 is 2 times 2 times 2. This is my prime factorization again. 8 is 2 times 4, 4 is 2 times 2, so 8 is 2 times 2 times 2. 12 is 2 times 6, 6 is 2 times 3, so there's my prime factorization there. And so my least common multiple, when I'm figuring that out, this one says I need at least 3 2's, this one says I need at least 2 2's. Well, if I have 3 2's, I make both of them happy, and that's actually the smallest number of 2's that will make both of them happy. This one says I don't need any 3s. This one says I need at least 1 3. So I do need 1 3, exactly 1 3. So my least common multiple here, if I was to multiply these together, I get 24. All right, 12. Again, starting by finding the prime factorization. I have the prime factorization right there, so I'll just copy it down. 45 is, well, let's see, 2 is not a factor here, but 3 is. 3 times 15 gives me 45, and 15 is 3 times 5. All right, so my least common multiple, I'm going to look through and say, okay, how many 2's do I need? This one says I need 2 2's. And doesn't chime in, so I'm going to need at least 2 2's. Well, exactly 2 2's. This one says I need at least 1 3. This one says I need at least 2 3's. Well, I'm going to need 2 3's then. Because again, I'm kind of going with the stronger requirement, because that'll make the other one happy as well. This one doesn't say I need any 5's, but this one says I need 1 5. So 2 times 2 times 3 times 3 times 5 gives me, let's see, here's a 10. There's 9 times 2 is 18, so this is 180. Or you could just plug that into the calculator. All right, the least common multiple of 28 and 42. Let's see, 28 is 2 times 14. 14 is 2 times 7. So there's my prime factorization. 42, I actually happen to recognize that one as 6 times 7. And 6 is 2 times 3, so we got 2 times 3 times 7. That's, of course, not the only way I could have gone about that. I could have done 2 times 21, and 21 is 3 times 7. I just don't want you to feel like you have to do it the way I'm doing it. If you want to do it with the prime factorization tree, that's perfectly fine. LCM. Okay, so finding the least common multiple, I need to figure out how many 2's I need. I need at least 2 and at least 1. So if I have 2 2's, that will make both of those happy. This one doesn't chime in about 3's, but this one says I need 1 3. So I need 1 3. And they both say we need at least 1 7. So we need 1 7. Multiplying these together, let's see. This is, actually I recognize this number right here is 42 because it's written right there. 42 times 2 is 84. When you're multiplying numbers, it's handy to notice things like that sometimes. 2 times 3 times 7, that's 42. So 42 times 42, oops, whatever, gives us that 84. Or again, you could plug it into the calculator.